You open this store probably 10 times a day without giving it a second thought. You grab the milk, maybe some leftovers, and you trust that everything inside is perfectly chilled. But have you ever stopped to ask, how does a box of metal and plastic actually keep things cold? Most people assume a refrigerator works like an air conditioner, just blowing cold air onto your food. Or maybe that it creates coldness the way a heater creates heat. But here is the mind-bending truth. Your refrigerator doesn't make cold. In fact, scientifically speaking, there is no such thing as cold. Cold is simply the absence of heat. It's what is left over when you take the energy away. So your fridge isn't a cold maker, it is actually a heat thief. It is a machine designed to kidnap heat energy from your groceries and smuggle it out into your kitchen. To understand how this heat heist happens, we have to look at a strange property of liquids. You know that water boils at 212 degrees Fahrenheit, turning from liquid to gas. But what if I told you that you can make a liquid boil at room temperature or even below freezing? It all comes down to pressure. If you lower the pressure enough, a liquid will boil and turn into a gas effortlessly. And here is the magic trick. When a liquid turns into a gas, it absorbs heat. It gets greedy for energy. Relatable and practical, using a common experience to ground the science. You have felt this yourself. If you put some rubbing alcohol on your hand, it feels cold. That isn't because the alcohol is refrigerated. It's because the alcohol is evaporating. It is turning from liquid to gas right on your skin. And to do that, it is stealing heat from your hand. Your refrigerator is essentially doing that same alcohol trick, but in a closed loop, over and over again, 24/7. It uses a special chemical called a refrigerant that can shift between liquid and gas very easily. Let's strip away the plastic and shelves and look at the skeleton of the beast. There are four main characters in this story: the compressor, the condenser, the expansion valve, and the evaporator. The journey begins at the bottom or back of the fridge with the compressor. This is the heart of the system, and it's usually the part that makes that humming noise you hear at night. The compressor's job is simple but violent. It takes the refrigerant gas and squeezes it. It crushes it. When you squeeze a gas, you force its molecules closer together, and this friction creates immense heat. Think of a bicycle pump. If you pump a tire really fast, the hose gets hot. That's exactly what's happening here. The refrigerant leaves the compressor as a high-pressure, super hot gas. Now, we have a problem. We want cold, but we just made a lot of heat. This is where the condenser comes in. These are those squiggly black coils you used to see on the back of old fridges. As the hot gas travels through these coils, it meets the room temperature air of your kitchen. Since the gas is hotter than the kitchen, the heat naturally flows out of the coils and into the air. That's why the space behind your fridge is always warm. As it loses its heat, the gas calms down. It condenses. It turns back into a high-pressure liquid. It's still warm, but it's no longer a hot gas. It is now a liquid waiting to spring a trap. This leads us to the tiny, unsung hero of the whole operation, the expansion valve. Sometimes it is just a thin piece of copper tubing called a capillary tube, but it performs a miracle. The liquid refrigerant is pushed through this tiny opening under high pressure, but on the other side of the valve there is a lot of empty space. The pressure drops instantly. When the pressure drops, the liquid expands rapidly. It boils instantly, turning into a gas. And remember our rule from earlier? To turn into a gas, it needs energy. It needs heat. Since there is no heat source right there, it uses its own heat to make the change. The temperature plummets. In a split second, the refrigerant goes from warm to freezing cold, around -15 degrees Fahrenheit.
Now, this freezing cold mixture of liquid and gas travels into the evaporator. These are the coils hidden inside the walls of your freezer and fridge compartments. This is where the theft happens. The air inside your fridge flows over these icy coils. The heat from your leftover pizza and your soda cans is transferred to the refrigerant. The refrigerant gladly absorbs this heat. It finishes boiling completely, turning into a pure gas again. It has successfully captured the heat from your food. Now, carrying that stolen heat, the gas travels back out of the fridge, down the return line, and returns to the compressor. The cycle is complete, and it starts all over again.
But the cycle isn't the only thing that matters. We also have to talk about the insulation. All this cooling work is useless if the heat from your kitchen just walks right back in. Modern fridges use thick layers of polyurethane foam and magnetic rubber gaskets on the doors. These seals are critical. If they fail, your compressor has to work overtime, running non-stop to keep up with the invading heat. So, how does the fridge know when to stop? It doesn't run 24 hours a day or your food would freeze solid. It uses a thermostat.
The thermostat monitors the temperature. When it gets too warm, it switches the compressor on. When it hits the target temperature, it cuts the power. It is a simple on-off switch that keeps the balance.
Intriguing, creating a mystery about the two compartments. There is one more mystery to solve. If the freezer is the part making the cold, how does the fridge section stay cool but not frozen? In many fridges, the answer is a simple trap door. A fan blows the cold air from the freezer coils. An electronic damper, basically a little motorized door, opens and closes to let just enough freezing air into the fridge section to keep it at a perfect 37 degrees. This technology has changed civilization. Before mechanical refrigeration, we relied on ice harvested from frozen lakes in winter, stored in underground pits, and delivered by horse and wagon. The ability to control temperature allowed us to build cities in deserts, transport fresh food across oceans, and store life-saving medicines. It is arguably one of the most important inventions in human history. But it's not just about keeping your milk fresh. The principles of thermodynamics happening in your kitchen are the same principles used to cool nuclear reactors, liquefy oxygen for rockets, and even condition the air in the International Space Station. It is a reminder that the universe follows the same rules everywhere. Whether you are launching a shuttle or just chilling a soda, you are manipulating energy, pressure, and the states of matter. So the next time you hear that hum coming from your kitchen in the middle of the night, don't just ignore it. Listen to it. That is the sound of a hard-working machine, fighting a never-ending battle against the natural heat of the world. It's squeezing, cooling, expanding, and absorbing. It's stealing heat to bring you the luxury of cold. And it's doing it all with some fascinating fundamental physics. Physics is everywhere, even in the most mundane appliances. If you want to uncover more hidden science in your everyday life, make sure to like this video and subscribe. We have got plenty more mysteries to solve together, from how your microwave cooks to how your phone knows where you are. Thanks for watching and stay curious.